compiler, it is a completely separate step during the compilation process. The C preprocessor is basically a text substitution tool, and it tells the compiler to perform some pre-processing tasks before it actually compiles the source code. Sometimes the C preprocessor is defined by using CPP, not to be confused with the C++ source code file, which has a file extension of .cpp. In C, CPP is referencing the preprocessor. All of our preprocessor commands start with the pound sign or the hash symbol. The pound sign or the hash symbol should be the first non-blank character for readability purposes, and we frequently will have it located in the first column of a line of source code. So we've already worked with the idea of creating global constants by using the pound define. pound_define also calls these macros. So we can do a pound_define, max array length, and its value will be 20. Anytime we want to reference that value of 20, we can do the max array length instead. Pound_define for constants does create increase readability. We use the pound_include to include either a C library header file or a user-defined header file. For using a C library, increase readability. We use the pound_include to include either a C library header file or a user-defined header file. For using a C library header file, though the file name will be enclosed in angle brackets, if it's a user-defined header file, we will place those angle brackets with double quotes. So here I am using the pound_include standard.io.h. Essentially what this is doing is taking all of the contents of that standard.io.h header file. I'm including it here in our program for our needs. Here I have that constant or macro debug, and it has the value of 1. If we have defined a macro or a constant and we want to redefine it, we would initially start with the undef. The undef is short for undefined, and it will remove the initial definition of file size and assign a new value to it with the next line that with the pound_define, file size is now 42. There is logic constructs built into the preprocessor functionality. File size is now constant, and we want to redefine. It. We would initially start with the undef. The undef is short for undefined, and it will remove the initial definition of file size and assign a new value to it with the next line that with the pound_define, file size is now 42. There is logic constructs built into the preprocessor functionality. So the if-def asks if a macro has been defined, and so if that macro debug has been defined, we'll have some output here or some functionality, source code written, and then we must end that if statement with a pound and if. So here I ask to see if message is defined. If it is not defined, then we will define it here as you wish, and then I have my ending if. We can have a pound if ndef. This means if not defined, and if that macro has not been defined, we can define it now. We have that same behavior here. So both of these actually do the same thing. We can say if ndef, or we can say if not defined. Either one of those will work. So both of these actually ndef. This means if not defined, and if that macro has not been defined, we can define it now. We have that same behavior here. So both of these actually do the same thing. We can say if ndef, or we can say if not defined. Either one of those will work. So we can use a pound if to test if a condition is true. If it is not true, we can follow that with a pound else. So you can see the same construct with the see, if, else functionality. And then if we need an else if from a preprocessor perspective, we would use the ELIF. ELIF is else and if combined as a single statement. Again, when we're using any of the pound if variations of preprocessor commands, they must end with a pound and if. We can also use the pound error. We learned in the previous discussion when we were talking about input and output that one of the standards is standard error. So we can use the pound error in order to access information stored from standard error and output it to the screen. So here I'm going to demonstrate the macros. So these macros are predefined. This is actually 2 underscores. before and after the all uppercase term. So I have date, which will give us the date, time, which will give us the time, file will tell us the location of the current file that we're working in, the line will give us the specific line number associated with that source code, and stdc will tell us whether or not we are using the ANSI C standard of our compiler. So here in the function macros, I'm using these 5 macros that are predefined from the preprocessor. So you can see that with the file, it gave me the fully qualified path to where this source code file lives. This is my current date. This is my current time. This is the line number associated with this line of code. See, it's on line 53, and it gives us the feedback of 53. And we are definitely using the standard ANSI C. There's different preprocessor operators we can use. The first one we're going to look at is the map. Macro continuation operator. So many times macros are defined on a single line, but in the event that we need to have multiple lines, we would have to use that backslash. So here I have that function operators. I'm going to call this function message4. I'm going to pass these 2 arguments. This is defined as a macro at the top. So pound define, the function name, 2 arguments. Notice there's no data types associated with them. Here's that backslash for that continuation. The second line of this macro is a printf statement. To receive the data associated with parameter A, I have to use the pound directive to output it to the screen. Same thing with the B. I use the pound directive to output it to the screen. So this is going to replace pound A with the value passed as A, pound B with the value passed as B. When I call that function, or that macro, it's going to have care and white. So let's demonstrate this functionality. Let me comment out the macros and actually run that function. There we go. Okay. So there you can see the A and the B were replaced, and we output that information. So what we call this is stringize. So when we put the pound in front of that parameter, we're stringizing it. So the number sign or the pound sign or the hash, we use that in a macro definition only, and it converts that macro parameter into a string. So we saw that capability happening here. So A is a string now, B is a string. We can do token pasting. So token pasting allows us to combine two arguments. It allows for two separate tokens in the macro definition to be joined into a single token. So here is the token pasting we're going to demonstrate. So I named it token pasting to make it easy to understand. And it's going to receive a single parameter. So I'm actually combining stringize and token pasting together. So here I'm creating a string with the explicit text token, and then I'm stringizing the value that gets passed in. The value that's getting passed in is down here in our token pasting function. So here I have my local variable token 34. It's set equal to the value of 40. When I call the macro token paster, I only pass the 34. The 34 is now stored in this parameter n. I'm making a string out of it, so when I output this to the screen, it'll say token 34 is equal to, and then here I have a %d. So what value is associated with that? So what is token 34? Well, token 34 is defined down here in my function token pasting, and it stores the value of 40. So when I run this, this will output that token 34 is equal to the value of 40. So it's essentially the same thing as if we were doing a printf, token 34 equals %d, passing as an argument the variable token 34, but instead we're using token pasting. Token pasting is the double pound and then the associated parameter from our macro. I have two examples of this. The first one is token 34. The second one is token 50. Token 50 is set equal to the value of 100. Again, to the macro token paster, I pass the value of 50. As a result, here, this will become the string token 50, and then it will go find the value of variable token 50 and replace or do token pasting with the value stored there, which is 100. So you can see here, my variable from that function, token 34, does hold the value of 40. That variable token 50 from my function holds that value of 100. So we have the defined operator. So we have this preprocessor define, and it's used in constant expressions to determine. Determine if an identifier is defined using the pound define. If the specified identifier is defined, the value is considered true. If the symbol is not defined, the value is considered false or 0. So let's look at our function defined. So here I'm using if defined debug, which it is. We define debug up here at the beginning of our preprocessor commands as the value of 1. So debug was defined, so as a result, debug statements would be displayed. And then, of course, we have our necessary and if here. And then here is the associated message. Message has been defined previously. Up here, we define message as you wish. The last function we're going to look at is parameterized. Parameterized macros is very powerful capability of C and allows us to simulate functions using parameterized macros. So we could have a function written int square, receive a value, return that value. But we could simplify it as a macro. We can do a pound. Define the name, square, the parameter it receives, x, and then the result. So notice in parentheses, we're going to have the parameter multiplied by the parameter, same behavior here in this function. So I demonstrate that capability. We have a function called max. or macro, excuse me. We have a macro called max. So if we wrote this out as a function, we would have int max, int x, int y. If x is greater than y, return x, otherwise return y. We could turn that into a simple ternary operator. We learned about ternary operators, earlier discussion when we were learning about operators. So the if portion is here in the parentheses. After the question mark is the result if it's true. After the colon is the result if it's false. And then we return that value. We can simplify this into a single line of code here as a macro. So I have max, my two parameters, my ternary operator, functionality, if x is greater than y. In the event it is true, we're going to return x. In the event it's false, we return y. So then down here, in our function, I say max between 20 and 10 is %d. I call that macro max, pass my 10 and 20, and we get our result. And we see the max between 20 and 10 is 20. So macros with arguments must be defined using the pound directive before they can be used. The argument list is enclosed in parentheses and must immediately follow the macro name. Spaces are not allowed between the macro name and the open parentheses. So the structure of it is very specific. We have to be very careful to ensure that we write it properly. So notice the no spacing here, okay? So this just gives you an insight to some of the functionalities with the preprocessor associated with C.